Hi, good evening, friends. It's my third lecture on the assignment problems. In this, we are going to deal with assignment problem based on the unbalanced type. So here the problem is given as three jobs are to be done by four machines. Each job can be assigned to one and only one machine. The cost of each job on each machine is given in the following table. So here your matrix is given where see here number of the row is your 3, but number of the column you are having 4. So it is known as the unbalanced type of the assignment problems. So we will see how to solve this by the Hungarian method. So step 1, write the matrix as it is. It is your M1, M2, M3, M4. Job 1, job 2, job 3. It is your 18, 24, 28, 32, 8, 13, 17, 19, 10, 15, 15, 22. You have right here, since it is unbalanced type, balanced type, adding dummy activity, dummy row. Okay, so you're going to get step 2 as is 18, 24, 28, 32, 8, 13, 17, 19, 10, 15, 15, 22, 0, 0, 0, 0. Since it is your dummy row, right here M1, M2, M3, M4, J1, J2, J3 and J4. Now we will go for the row minimum operation. So you have to select the minimum value from the row, as it is 18, here it is 8, here it is your 10, here it is your 0. So we are, after doing in a row operation, we are going to get in a matrix as we have to subtract this row element within a minimum value of the respective row. So 18 minus 18 is your 0, 24 minus 18 you will be remaining with the 6, 28 minus 18 is your 10, 32 minus 18 will be your 14. Here you will be having 8 minus 8 0, 13 minus 8 5, 17 minus 8 is 9, 19 minus 8 is 11, 10 minus 10 0, 15 minus 10 as your 5, 15 minus 10 as your 5. Okay, 22 minus 10 as your 12, 0 minus 0 0 0 0 as it is. Okay, now for the column operation, since we are having in each column we are having single digit as a single 0 we are having, so after doing in a column operation we are going to the same matrix, so we skip that part and move to the next step where we are going to do the row and in a column operation sequentially in a given in a step 2 matrix. So it's now step 3. Zero, 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 0, 0. It is your 6, 10, 14, 5, 9, 11, 5, 5, 12. Okay, same it is here. M1, M2, M3, M4, J1, J2, J3 and J4. Now you have to do the row and the column operation. Okay, first we are going for the row operation. So in the first row number of 0 is your 1, so select that 0 and cancel that respective column. Now move to the second row, you are having none of the 0, skip that row, next move to the next row, again you are having none of the 0, so you have to skip that row. Now move to the fourth row. Here you are having more than one row, so you have more than one zero, so you have to skip that row. Now move to the column operation. In a column operation, see here, this is your first column. In this column you are having single digit 0, so select it and cancel that respective row. Now you're remaining within none of the 0 is there, so you have to skip. Now you have to stop here. Now see the number of the allocated values. Allocated values cell is your 2 only, okay, but the matrix is of 4 into 4 form. Since 2 is not equal to your 4, therefore you have to move to the step 4. In step 4, first draw the matrix 1 2 3 4 2 3 4 m1 m2 m3 m4 j1 j2 j3 j4. Okay, see here, these are your not uncancelled values of the element. So you have to, from this element you have to select in a minimum one. Suppose I am selecting 5, which is the minimum. Now these are the uncancelled element of the matrix. Now you have to subtract this elemental value with the minimum value. This is your, which is your 5 here. But if in the intersection point, see this is your vertical and this is your horizontal line. Here intersection point is your this element. So at the intersection point you have to add this minimum value here. Okay, further here it is a cancel out, so no need to add it here. The values of this element will remain as it is. So in step 4, here it just cancel out, so you have to write the element as it is, 0 0 0. Here is your intersection point, so you have to add this here. So 5 plus 0 is your 5. Again here is your uncancelled one, so you have to subtract it from the minimum value. So this is your 5, which is your 5. So 6 minus 5 is your 1, 5 minus 5 is your 0, 5 minus 5 0, 0 will be as it is, since it just get cancelled out. Now in the third column, 10 minus 5 5, 9 minus 5 4, 5 minus 5 0, 0 will remain as it is. Now in this column, 14 minus 5 is your 9, 11 minus 5 6, 12 minus 5 7, 0 minus 0 as 0 as it is. Now again you have to perform. Now you have to go for the step 5. Okay, here also you have to perform the row you have to go to the step 1, where we are finding the row minimum value. Since in each row you are having the minimum value as a 0. Okay, so if you are going to cancel that, you are going to get the same matrix, so no need to go for the row operation. Now for the column operation, you have to select the minimum value. Since in each column you are having a 0 value as a minimum, if you are going to cancel that, you are going to get in the same matrix. So skip that part and move to the next another step. Write the matrix as it is. Your 0 0 0 5 1 0 0 0. It is a 5 4 0 0 9 6 7 0. M1 M2 M3 M4 J1 J2 J3 J4. Now we are going to perform in a row and in a column operation at a time, but in a sequence way. So first we will perform in a row operation. Now in this row you have to select first you count how much 0 is there. Only single 0 is there, so you have to select that 0 and cancel that respective column. Now move to the second row. Here you are having a single 0, so you have to select that 0 and cancel that respective column. Again here, again in this row you are having single 0, so you have to select that and cancel the respective column. Again here you are having a single 0. Okay, so select that and cancel that respective row. Now in this case, since the number of allocated values what 1 2 3 and 4, so 4 cell allocated cell is your 4 is, and the number of the matrix is of 4 into 4 form. Since 4 is equal, its optimization is reached now. So now you have to go for the final step. Now step 6. engine is step 6. Here you will job, machine, and here it is your, see the question. In a question here said to find the value is given in cost, so you will get in a cost here. Okay, now here is a job 1 2 3 and 4. Machine number means that job 1 is completed by M1, so you have write 1. Job 2 is being completed by 2. Okay, for job 3 we got M3. For job 4 I got 4, so I write it here 4. Okay, now from the question, see here, for job 1 and work done by machine 1, time cost is 18. For job 2, work is done by machine 2, so cost is 13. For job 3, work is done by machine 3, cost is 15. Since job 4 is not there, it is a dummy, so you have to put it as a 0. Now add the value. You are going to get 46. So total cost is your 46, hence it is your answer. I hope you enjoyed. Thank you very much.